All right, how are we doing today? Doing good. All right, how was that assignment? Painful? Not painful enough? Let me get rid of that. Comp, not comp sis. Let me see. Was it Morris? Um, man, Dr. Morris. Let's see where you go. Let's see if he did anything. You guys seen this? Refresh. Nothing happened. Anyways. Is everyone good with going through the tutorial? It's not that bad of an assignment, right? Except if you're doing it like literally the hour before it's due. Yeah, then it becomes a little annoying, and you got the syntax and everything. Does everyone know how to append signals, right? For the periodic signal, where is the appending? Hint, hint, how to append things together, and you get this big fat signal, right? If this was a 1 by 11 and another 1 by 11, right? You can get a 1 by 22, right? The answer to get a periodic signal, correct? You guys got that? And then let me see what other things. You guys know what these things look like, and if I gave you a math homework, right? Problem, right? Just draw me this and do some funny calculations. You guys know how to siphon this guy out, right? Easy stuff. Code. What other stuff do I have here? Impulse response, generate more stuff. Let's see. You guys know how to generate this thing right here, right? Okay, let's start complaining. Yes?
Is that so? When I tried to plot that, it said it can only plot the real portions of it, unless they plotted it in both.
That is true. You know what? Let's go over that. So this is the same assignment I used from last week. Let's go over here. Let's do, I don't know, lecture EE 360D, lecture 2, Feb 4th. And then let's do complex signals. And let's do, let's do this. I don't know. So, there we go. I can't do a smiley face. Let's just do this one. There we go. Anyways. So let's just say, what's the assignment saying to me? Let me just check my recording. Okay. I got a lot of things on my head, y'all. I got to make sure everything's looking good. So generate this or what do you call it, complex signal. And what's our n? Minus 25 to 25. Anyways, let's do n is equal to minus 25 to I'm gonna shorthand this 10 to 10. If anyone copies it, you'll know who you are. R, was it R? Is equal to exponent, right? You guys use exponent, or was it E? Did E work? No? You gotta do the exponent, right? Didn't like it, huh? This one, and then there's two ways you can do it. You can either do 1i as an imaginary one, or you can just do J. But sometimes J can also be a variable, so do be very careful. Let's see if it barks at me. It does. Hover over it. It says, for improved robustness, use 1i. But honestly, I'm an engineer. I have OCPD. Screw that. So dot times, okay? What was my frequency? Let's see. My frequency was, okay, pi n over 5. Pi dot times n dot divide 5. Okay, and then is everyone doing figure something right? There's a way to do something cool with figures, where I think you can do like name my complex signal, and then you can do I don't know, this. There we go, and then let me see, stem N, R, all right? Is that easy? I didn't go over this over the last class, but are you guys titling your things? It becomes a lot easier, right? Let's call this one my R of N is equal to exponent. You know what? I'm too lazy. Boom. You see how you can save so much time? Just copy and pasting. For those who really, really are very picky about this class, let me show you another thing. You can do interpreter, LaTeX. Let me show you something cool. think it's like this. Let me see if I can do this for you. Dollar sign R n is equal to e to the, let me see if this runs, e to the j, see, 2, wait, no, j pi n divided by, and I don't want to do that. That's a little too hard. Do I remember how to do this? I think, let's see what this does. Okay, I want to see, and then you guys are doing your X labels, right? N, right? Are you guys doing this? Makes it easier for the grader. Y label, some value, right? Easy. Let's run it. Control Enter. Oh, warning! Can't do that. Oh, maybe it works if I do this other dollar sign. No, it didn't work. What I'm trying to show you guys, if you guys really have OCPD, like, hey, I need to go crazy. Nope, that's PCB layout. Whoopsies. That's a surprise for another day. Let text do fractions. Yeah, I think it was fraction. There we go, frac. That's what I needed. I'm very picky. I really love like having good documentation. Frac. What's in my numerator? Was it pi n? Yeah, and my denominator was 5. Let's see if this works. There you go. You guys like that? You see that? It's pretty cool, right? Can I do font size? Let me see if I can do font size. Font size 18. Boom. What the? Let's see. Must have invalid. Oh, whatever. X. Boom. Let me see if I can put this at the end. Run. Are you kidding me? Font size. Don't bark at me. Don't you just love MATLAB? The littlest things. This is the more annoying part. Once you start getting these like little things, you saw how I changed the font size of your titles? Makes it look bigger. Let's see. I don't know. Let's do 25. Really big. You like that? Looks cute, right? So you can, if you want, you can do this for your like extra homework or on your research. LaTeX libraries, you can make some really, really pretty graphs. So when you do like your research projects or senior design, junior design, any type of presentation, you thought Excel was cool, but you can do a lot of cool stuff with like formatting. Not just there too, you can also do it right here too if you wanted to do interpreter LaTeX. Let me show you. And actually, no, I don't want to waste more time, but is everyone clear that you're going to have to title your figures, right? What if I did this? Let me show you, %. And then let's clear all. Watch what happens when I do, no, not clear all. Close all. This is going to be your best friend if you don't like figures. I do, but see all these figures right here? Yeah, they get annoying. Enter. Wait, hold up. Enter. Where'd they go? Okay, so you don't have to press X, X, X and just go crazy. Anyways, is that good with everybody? Actually, let me run this again. What is the signal? I don't know. You see, so I want to make sure you guys can reference this too. Make it easier for her, because if it makes it hard for her, she's just going to say -1, right? Yeah, I see. She's busy too. She's doing her prelims or qualifying, or you already passed your dissertation. So make her life easier, all right? I want to make sure she can go home and sleep too. Anyways, any questions about this? I'll give you guys as an answer. Oh, how to actually make sure it's running. So when n is 0, right, this is just e to the 0th power, right? What does that equal? 1, right? Well, what's the complex number? It's just 0, right? So if you wanted to do something, let me show you this, okay? It's called the subplot function. Subplot. Let's do 2 rows. Do I want to do 2 rows? 2 rows, no, 1 column, 2 rows in the first position. And let me do this. I'm gonna call this one R real, right? R imaginary. Imagine Dragons, I don't know. Let's see. I'm gonna do this because I'm OCPD'd. Boom, boom, right? Same function, right? Let me do this. Real of this, right? And then I think it's image. Yeah, image, yep. There we go. And then this right here is the real component. This right here is the imaginary component. Okay, is that good? So I'm going to do subplot. Okay, so you're going to be using subplot a lot in this class too. When we're talking about convolution, you're going to compare x, h, and your output y. Is that good? Anyways, okay, stem. This is going to be our R real, right? My real signal, right? And if you really want to, you can just do, let's see. Let me do this. If you do this, watch this. Let me see. Okay, real part of, okay. And then if you can literally just copy paste this. Boom, boom, boom. I'm gonna call this one my imaginary part. R imagine. Yeah, there we go. Let's see if this works. Looks good. Control Enter. Well, didn't like me there. Let's see. Oh, you gotta. So this is our second element. So subplot, right? One row, two columns in the first position. So 1 by 2. There's only 2 positions, right? I'm gonna put this in the second position. Boom, right? But now you got to deal with all these titles, right? Let me see. Let me change this up. I'm gonna do 2 rows, 1 column. 2 rows, 1 column. Let me change the what do you call it? Font size to, I don't know. Let's do 14. That should be fine. 14. You guys, like I'm doing your homework. Does that look good? No, because it's not looking good for me. I know, man. I know it happens. I'm too lazy. Let's see. You can do this. You have my permission. Just go to your other parts of your assignment. Boom. R fill. Let me create this as a green signal, and then let me create this one right here as a, I don't know, red signal. I'll use K for black. Guys like that? Looks cool, huh? Guys like how I just did that homework assignment for you? You like the answer? It's not the real answer. Just change this to 25 minus 25. Not that hard of an assignment, right? Any questions about how I'm doing this? So yes, if you want to use subplot, be my guest. This is how you do it. You can do it like that. 2 rows, like how many rows, how many columns? If I have 2 by 2, right? So if I want to do 1, 2, 3, 4, there's 4 positions you can choose from. You can also mix them. Let me show you something cool. If I were to do like 2 rows, 1, yeah, let me just show you, for example. Okay, I'm gonna do something like this in the first position and in the 4th position. Boom, you guys like that? Let me show you something even cooler. You can do this. I'm gonna do this for the second plot. 2 rows, 1 column in the, let's see, second position. You can also do that trick there too. All right? So the way the figures work is it does a mathematical calculation. How big is that? 1, 2, 3, 4, right? 4 positions. And it tries to squeeze it into like, oh, I can put this in 1 or I can put this in 2. Watch this. Pretty cool, right? What if I did this? Position 1. It's going to overwrite it, okay? But I can also do this too. You can start playing around with MATLAB. See how powerful it gets, okay? I'll give you that in an answer, but don't copy it. Just rewrite it. Any questions? Yes? 2 signals on the same plot. Okay, let's see. You know what? Let's do this problem again. Let's do this problem again. And I'm going to call this one, you see how copy-paste starts becoming your best friend? Doing it again. Let's see. I'm going to honestly reuse this. Let's see. I don't think I'm going to go too far. So let's not do subplot. I'm going to do it in one plot, okay? Okay, this is good. Let's do this, okay? You guys like that? Okay, and I'm not using subplot because I'm going to hold on, okay? Hold on to your data, okay? And then boom, 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 keep that. Get rid of this because I'm not talking about that anymore. I don't need this because we're holding on to the previous information. Should be, let's run it, see what happens. You like that? But now you need a legend, okay? Because can you tell me which one's the right signal from this? No. All right, so you can do a legend like this. Legend. I forget how to use it. Let's see. Label. The first one is going to be, maybe I didn't have to delete part. Real part. And then, let me see. Imaginary part. And it goes by order, okay? So if you ran this, it gives you the order. All right, real part, imaginary part, all right? And then if those who have OCPD, you can also do this. Location, best. Okay? It tries to find like the best position that doesn't cover the most data points. You like that? Looks good, right? Grader's gonna be happy. It's a really powerful system, okay? I want you guys learning this because you guys are going to be, if you guys go to signals domain, controls domain, communications, you're going to be seeing this every day, okay? And especially, I see this a lot for your thesis, or there's thesis documentation. You can completely make or break like a whole billion-dollar project by having really good figures, all right? Data sharing is good. Yes?
I think the assignments are already written, but I was thinking, is there a way to just practice formatting? Just in the formatting sense of to get presentation?
Kind of. I wish. Honestly, formatting is somewhat, there's minimum formatting. That's a strict rule. I think I even have, okay, I'm going to have this on my recording. We are recording. Here we go. Let's go to home. Let's see. No, this is not the right module. I did post some kind of formatting. Not really. Let me just show you. Was it under pages? Final exam. Plain no. Front page. View all pages. My 360D content that I did. I did post this. You guys see this right here? How I want things to be formatted. Right? Here's your master title, section title. This is how I create chapters, correct? Do I have how to publish figures? Ooh, look at that. Oh, is this your answer solutions? Like that? Generating signals? You guys like that answer right there? Yeah, copy paste that. Clear sections, visible code, and title figures, right? Is that good with everybody? You like that? Back of the page is blank. This is if you try to, we did physical submissions years ago, but honestly, digital is the way to go. Don't kill plants, don't kill trees. You guys like that signal, HFN or whatever this answer? Yeah. Is there a solution to this one? I didn't give you a solution. It's okay. Page number. Cool? But yeah, in terms of advanced formatting, I can try to touch it a little bit, but honestly, that's not the focus of the class. It's just making sure you guys can use the system. Are there any questions about how to approach this homework assignment? Everyone's good. Everyone knows how to do digital sampling, right? We're sampling right here. Yes?
How are we going to put it into a 3x3 grid using the subplot?
Just do 3x3.
3x3 by 1?
Yeah, so that puts it... Okay. This is the class to learn it, y'all. Anyways, let's do it right here. 3x3. If I don't change the numbers, watch what happens. Right? This is position 1, 2, 3, 4, right? If you want to play around, this right here, let's call this one position 5, right? Does that make sense? Or better yet, let me show you something cooler. If I did 3 rows, 1 column in the first position, right? 3 times 1 is 3, right? All right? So there's only 3 positions. So if I put it in the first position, you like that? Or if I put it in the third position, also like that? Does Sounds cool? You can do a lot with subplot, okay? Any questions? Any more questions about computer assignment 1 before we start talking about convolution? All good? Anyways, assignments due tonight. I think it's like infinite resubmissions until midnight. So good luck with that unless you guys want to do it right here, right now while I'm still here. Anyways, so let's see. Dr. Morris didn't get the assignment ready, so you guys, let's see what I have. F25, let me see. UNLV, let's see, 360, boom. Unilateral Laplace transforms. Let's go to my last semesters. This computer assignment 3 is what he wanted me to look into. Fall 2025. Yes, if you know, Dr. Stubrud is our main MATLAB person, so he's the one who goes crazy with these assignments. So anyways, how's the lecture going, by the way? What are you guys doing? Convolution, did you guys just started that? All right, let me see. Because I don't know what his assignment Dr. Morris is going to try and present to you guys, but he did say, that's why I called him, how to actually do convolution. There is a few things. Let me see. You can use the circ-shift function. There is a built-in convolution, but let me show you what I did for my last year's class. We had a really good, what do you call it, assignment. Let me see. F25, where was it? Where is my convolution? One of these guys. That's my discussion. Where is my... I have it here. Give me a second. Did I not publish it? Lecture. There it is. Week 11? Nope. Week 12? Monday. Yeah. It's one of these guys. There you go. Let's click on that. So I did develop like a way you can do convolution. Let me just show you. Let's see who wants to be a, what do you call it? Watch my integrals. Let's see, pull out my markers. I didn't think I was gonna write too much. Anyways, let's see, go to my screen right here. Convolution. Okay, whatever. There we go. I'm calling this one February. Wait, there we go. Feb 4th, 2026, page 1. So, what do you guys know about convolution? Yes?
I mean, I think you could use Laplace transforms to.
We're not going that far. We're talking about like the foundation of what it is. Yes?
You're essentially taking your X and N signal and your H and N merging them.
Okay, yes. Did you guys do the analog and digital versions?
No, it's flip and drag.
Just flip and drag. So you guys, have you guys seen this? If I were to do this for you, you got the whole summation right. Was it k from minus infinity to k to infinity, right? Let's see, was it x of, let me see, minus k? Or was it n? The signal itself? K, and then h of n minus k. Is that correct? Am I passing this class too? Anyways. So we're taking our actual signal, right? And it's if I were to do something funny, here's my signal, right? And here's my other signal, right? This is x, this is h. Let me just make that bigger, sorry. There we go. Let me do this. This is my x right here, this is my h, all right? I'm taking, here's my x, right? It just frozen in time, right? So then all I do is just take my h, right? And if I have a negative k, right? If n is equal to 0, right? So now I have this case where it's like, let me do this problem. Let me see, pink. If I were to do y of 0, right? The first point, correct? Is going to be the infinite sum of k infinity to k minus infinity, right? Right? Is that good with everybody? Of x of k, right? And then h of minus k. Is that good with everybody? What is this going to equal? It's going to equal, let me do this, x of 0, right? H of 0, correct? And then if I were to go forward in time, right, k is equal to 1 now, right? Plus x of 1, right? But hey, this one's going to be minus 1, right? Is that good? And if we go backwards this other way, it's going to be x of minus 1, right? H of 1. Is that good with everybody? So how do I represent that? So here's my x. I'm using too many colors. Here's my x, right? It's just chilling. All right? I'm at 0.0, right? Okay, here's my h. Flip. Do they touch? Not really, because you just got to add everything that's in there. Now I'm at, let me do another marker. Oh boy, David, you're going to be so resourceful this year. Let me do y of 1, right? Okay, I just go one more step, correct? I have the same infinite sum, right? K is equal to positive infinity, minus infinity, right? X of k, right? But now it's h of 1 minus k, right? Is that good with everybody? So what does this mean for your h signal, right? Your x of k is just frozen right there, right? It's just chilling, okay? But now your h, it just kind of goes one more to the left until you're just doing this thing where you're adding the signal. So if I were to tell you the signal, like, hey, these don't overlap together, but like, look, we have this tiny piece, these two go together, they add the whole thing together, and then you start seeing this, like, it just moves around over time. Is that cool with everybody? Anyways, and then there's the analog version. Let me see. I wonder if I can see Dr. Morris's stuff. Let me see. Will it let me see? Where does he keep his stuff? Pages. External stuff. I guess he keeps it in his main page, huh? Let's see. Reading, notes. Is it this one, comp 2? Let me see if he uploaded it. He didn't upload it. Okay, it's okay. Let's look at this. Convolution. Did I get it right? Yeah, I remembered it. Sounds cool. Convolution. Yeah, I know. Does he go over... What do you call it? He doesn't go over the domain one. Okay. Order of convolution does not matter. It doesn't matter. So it can either be... What do you call it? It can either be x of k, h of n minus k, or you can do h of k and then x n minus k. But I think typically it's h in here, and then you're just moving your input because that's always moving. Let me see what else. Does he go over integrals?
Oh yeah.
He does go over integrals. Okay. But I'm wondering what he's going to do, and then literally there's your time or your analog version. Is that good with everybody? So I'm just going to refresh it for everyone's minds. When we're analyzing the output, right? Okay, we're not doing like, oh, we're just multiplying or we're just adding the signal, right? We're not doing that. We're taking one input. Let's just say your box, literally like, do I have a representation? I don't know. Here's your factory, right? That's your impulse response, okay? That's a hint for a future video. You can't change your system. This is your RC filter, all right? But what does change is your input. It just sneaks in there. That's what we're doing. We're looking at your entire system, right? Your entire system, and we're just sweeping your input going inside. So if you wanted to do this, you can also do this. Equals k is equal to infinity. K is equal to minus infinity of h of k. I'm used to this one. X of n minus k. This h of k is your impulse response. It's your factory. I can't really do anything unless I just, that. But your signals are what is just going to start moving around the page. Is there any questions about that? No questions? Let's see. So let's see how Dr. Morris wants me to do this. Let me see. Is this my page? No, that's not my page. Let's see. Where did I put the assignment? Right here. Because there's a few ways you can do this, but I wonder how he wants to do your convolution. Let's go over an example. I like examples. I developed this little script for my 360 students last semester where I try to do analog convolution, but let me see. Do I want to show you this? Yeah, let's just develop something. Actually, not this. Let's go over here. Doing convolution. Let me see. So let's just say I have, I'm going to go clear all. Let's do n is equal to, let's see, this is 0 to 10 or something like that. X is equal to, how do I want to do this? Let's see. I'm trying to figure out a good signal for you guys to do. Let me see. Let me check my other assignment because I wonder what we should do. Computer assignment, assignment 2. Let me see my previous one. He doubles it. Okay. Because I need you guys to know. You guys haven't talked about linear time invariant systems, right?
Not really.
Or not really? Yes? No? How do you? Oh, bless you. How to use like feedback or how to actually use for loops, or did he show you how to do that? Yes, no, maybe? Let's see. Yeah, difference equations. He's not talking about difference equations? Not yet?
I know where.
You know it, but anyone else? No, we're not talking about that? Okay, so we're just going to go brute force because I don't want to show you guys this yet. So let's see. How do we want to do it? Convolution. You know what? Let's try this. But what's my x? And let's just do something funny. I'm gonna create a signal. It's gonna be let's see, zeros. No, let's do ones. We're gonna do one row of, let's just do 5 0 or 5 1s. Okay, do this right here, and then I'm gonna do zeros. One row of 5. Is that good? No, we have 11. So I'm gonna show you some powerful ways to do code. Length of n minus, I don't know, something. There we go. And then let me do zeros. Length of n minus something. Let me see, because I'm trying to show you what I'm trying to show you. I want to do like 2 1s and then the rest are zeros. Are you trying to? I'm trying to use this something part as like my actual like variable that I'm changing. I'm trying to make it easy for myself. Let me see. So if this is 11 and I want something to equal 5, right? So that will be 6 right here. So that means I need this to be 5. Or better yet, if this was 0, right? This is going to be 11, right? And then this right here has to be 0. So length, something. Does anyone help me out with the logic? Let's see. This is 11 because I want this to be if this is 11 right here, this has to be 0. If this is 10 right here, this has to be 1. Can anyone help me out with that logic? I'm thinking like I think it's as easy as, let me see. This is 11. I'm not thinking right now. And let's just see what happens right here. Let's run this. Let's see what happens. There you go. Now here's my x, okay? 12, I got 5 there. 1, 7 right there. Let's see. You know what? I think it's as easy as this. Is that right? Let's see. No, that's not right. Because this is 11. No, that wouldn't exist, though. No, that wouldn't exist. Length n. I'm making this too complicated. 6, 5. Anyways, no more thinking. Okay. And then I'm going to copy this right here. I'm going to call this one H. And let's make this one, I don't know, 3. And this one, there's 3 there. That means 11, 10, 9, 8. 8 right there. Is that good? So now what I'm going to try and show you guys is a for loop. For I, or let's just do k is equal to, let me see, k is equal to, let me see, because we want to access this element, but we need to flip this guy right here. Let's just do from n. We'll see what happens. And no, don't do that there, because I'm trying to do y of, let's see, x of n, h of n, y of, let me see, because we're going from 0 to 10. This has to flip around. I'm already seeing a problem. So k is equal to x of k. I'm just going to write this for now, just for my sanity. H of, let me see, n, no, because let me just do this, minus k. Because this is not going to work. This is not going to work for sure. I'll tell you that now. Give me a second. So if I'm doing it for one element, okay, so that means, let me see, for I is equal to, let's see, for I is equal to 0 to, because, let's see, we have this one, let me see, I'm trying to figure this out. 0 to 10, 0 to 10, okay? We're sweeping this number, okay? We're sweeping that one, which means I just want to do this point right here. But this title is not going to look, it's not going to be what I want it to be. Unrecognized variable k. And let me see. I'm trying to show you the brute force way of doing convolution. End. Boom, boom, boom. Is that good? So if I'm starting with my first position, right? There we go. My first position, okay? That's my first position. Y of n. There we go. This is y of n. Just imagine this is n, okay? Actually better, I'm going to call this one n time, okay? Doesn't confuse everybody. For n is equal to 0 to 10, okay? Are you guys understanding the annotation I'm doing right now? I'm calling this one my n time, okay? This is the n time that I'm dealing with these two signals, okay? Better yet, let me just generate this. Figure 23, whatever. Stem, n, time, and x. And then subplot, 2 rows, 1 column, first position, title, x of n, x, yeah, let's just do x of n, and then let's do subplot 2, 1, 2, stem, n time, h, okay, is that good? Title, title, h of n, okay, run that. It's gonna bark at me because I didn't know what to do. You like that? 2 signals? Let me see. Let me just make them a little more pretty. So I don't want to focus too hard on this because I don't know what he wants to throw at y'all, but I'll see what I can do. Let's do anyone colorblind here? I don't know. Let's do red, green, easy. Don't worry about the barking. x of n, right? And h of n, right? But I'm going to try and flip this h of n, okay? Is that good with everybody? Because I'm going to try and do convolution. So we're going through the whole signal, right? We're going to go from minus infinity to infinity, okay, of the entire signal. And our signal of choice is going to be this guy right here. We're going to be sweeping this, and we're going to fill out all the holes. We only have 10 points, right? Actually, I don't think I like that either. Let me see. I don't know if I want to go too crazy there, because you're not going to get it. Ooh, yeah. I don't like this. Because if you flip this, it's flipping onto things that doesn't exist. Let's comment that out. I think we're making life too hard. You can do Control T. No, Control R. There we go. Let me just show you what I was trying to do. You see. Sorry for wasting your time. Help conv. There's one last thing I forgot to tell you about. Is convolution doubles your signals. Your output signal is going to be a little funny, okay? Let's see. There we go. There we go. Yeah. W is a vector. Okay. If this is W, right? This is U. This is V, right? Length U, length V. The output is going to be a length of both the elements, both the arrays, minus 1. So if we have a signal of 11 elements and another signal of 11 elements, it's going to be 22 minus 1, so a length of 21. You see what happened? That's why I kind of paused myself, because honestly, I don't want to put you through that pain. Anyways, this is what I was trying to do, because I'm trying to figure out what he wants me to show you, but I'll show you the cheat way. This is with this assignment right here. How to use, what do you call it? The con function. This right here, h of t of n. Convolution in general, let me see. Output is your delta function. Difference equations of non-recursive systems are typically written like this. Direct form 1 and direct form 2, often expressed as this. I think this is the hint of the day, y'all. Maybe I can show you convolution once and for all. I think I know what he's talking about. I see. Y is equal to, because we got to sweep through every element for K. H of T, H of M, okay. Yeah, give me a second, y'all. I'm trying to figure this part out. H of M and X of N is equal to that. So if I were to do the following. So the reason why I'm pausing right now, let's just say M is like, let's just say 2, right? So you're going to deal with 0, 1, and 2, right? So if we were to flip this, we're only going to have 3 values, 3 summations, okay? So we're going to add this 3 times. So we're going to do 3 points here, 3 points there, 3 calculations to get you 1 point. And that's kind of what Dr. Steerroot had right here. So I'm trying to see if I can show you what I'm trying to do. Here's my signals, okay? These are my happy signals. I like these signals. And that one barked. Where's my thing? Run this, run that. I'm trying to show you what's going on. Is we need to cut just this part, okay? Because if I try to show you other things, it's going to look a little too funny. Anyways, for I is equal to, because I want to make sure I can do this right for you guys. Let's see. I is equal to, let's see, 1 of length, no, not h. Give me a second, y'all. Because this one stays the same size. This one doesn't. Give me a second, y'all. I wish I can figure this out for you guys. Because this right here is one of the answers, and I don't know why I'm not thinking right now. Because I want to get this. That's the size of the signal. Remember how I was talking to you about, here's my factory that doesn't change, right? This right here is my, let me see, even I have brain fart. This right here is my factory, right? And this is my signal. So what I'm trying to show y'all, let me see if I can do this. Hold up, I can still save this class. I'm gonna brute force that, okay? So now that's a smaller signal, okay? Length of h, okay, that makes sense. Y is equal to h. Let's see, y of, let me see. We're dealing with time, okay? I'm trying to figure this assignment for you. K, we're gonna go through every point of K, h of t. Let me see. Y of, oops, sorry. Y of I. There we go. I, 1, 2, 3. Is that how it's going to work? Let me see. No. Length of x. There we go. So we're going to go through every point of x, okay? If there's, how many elements in x? 11 elements, right? We're going to go through every point of x, okay? But I only have 3 points of h, okay? So for every point h, okay, I think I'm getting it. X of, let me see. I want to see if I can do this. Wonder if this works. Let me see. Call this one x flip is equal to x from, let me see, I to I, size, no. Let me see, hold up. From the first element to the end, do this, end to -1 of 1. Let me see what this gives me, okay? Because I'm trying to flip this signal, okay? F9. Did that run? Okay, it did flip. And I just want these 3 points, okay? So if I were to do the following, we're going to do some hard mathematics right here. Okay, I just need those 3 points. X of m. I just need 3 points. The size of this, 3 points, 1, 2, 3. And then x flip, extract 3 points. Let me see. I to I plus 3. Let's see if this works. X flip. There we go. Let's see if that works. Anyways, I'll have something prepared for y'all. Let's see why it barked at me. X must be the same length as Y. Filled. Give me a second, y'all. What did I mess up? Doing convolution. Boom. X, H. Where am I messing up, y'all? Doing stem. Line 102. Nope, didn't like that one. N time H. Oh. Because I changed this, it starts barking here because it says it doesn't like that signal. Anyways, I'm just going to uncomment this, okay? Boom, boom, and then boom. Don't worry about that. I just want to know if this worked. Okay, don't worry about that. Let's see. What is H? H is how big? It's a 1 by 3, right? So that means X flip needs to be a 3 by 1. 1 by 4. 1 by 4, okay. Boom, boom. Oh, I didn't do this. There we go. I didn't transverse it. Now this should run. Hello. Let's see. Index exceeds the number of array elements. There's a problem here. -3, whatever. It ran. Okay. Stem, figure 12, whatever. Stem Y. Oh. Hey, it worked. Whew. Now you just gotta fix your timing. Let me just do from 0 to size or length. This is cheating. Don't do this. Or unless go ahead -1. There we go. Maybe it's 1. No, didn't like 1. Was it 2? Yeah. But it didn't do what I wanted to do here, so I messed up something right here. X flip. Oh. No, I gotta go backwards. I flipped this around, okay? But I want to do the last ones. End. What do you call it? End to end -2. Is that correct? -1. No, it didn't work. Because I want this. Okay, I flipped this, okay? Here's my X flip. Oh, that's not what I wanted. Here's my X, okay? Right? And then I'm going to flip it, okay? F9. Right? And I just want these points. Well, at the end, this one needs to be my first, second, third, and then we're going to go from this. So end to n minus this. And then it's going to be n -1, then doom. So you know what? I think it's this. N minus I plus 1. There we go. I'm doing some mental gymnastics here. Plus 1 minus 2. Is that close enough? No, I don't like that. But anyways, are you guys seeing what I'm trying to do? Brute force. There's another way you can do it, and here's the true answer if you really wanted to go crazy. There's a function called convolution where you can do this. Y out is equal to conv x, right? H figure 6, 7, yeah. Stem. What do you call it? Stem Y out. And then X label time question. Y label value. There we go. That's your answer. Oh! See that? You guys like that? That's the convolution function, okay? I was trying to replicate that. So you see, guys, I was getting close. But point is, when you take that x event signal, let me show you. Like you saw those two signals, right? And you put them like, you just make them go like over each other. You're going to see the point where literally it's like it goes up and then it saturates right there, right? Boom, and then it goes back down. Is that cool? Does that look like something you guys did in your class? Any questions? Assignments due tonight? Computer assignment 1? When's computer assignment due to 2? Or what? Is it next week or 2 weeks from now?
It's bi-weekly, right?
Is it bi-weekly or is it weekly? Let me check.
February 10th.
So it's on recording so that no one's like, hey, due 11, 2/11.
Next week.
All right, get working. I have a good day.